Good morning, children. The next chapter that we're going to start is chapter number 3, Force and Pressure. Okay. So, force is a term that you've been studying from your lower classes. What comes to your mind when you think of force? Yes, push or pull acting on a body is called force. That's the definition you studied in your lower classes. But now, let's see how the definition goes. Before going into the definition, first of all, effects of force. Okay, what a force can do. When you apply force on anything, 4 things can happen. Okay, 4 things can happen. We are going to see those are called effects of force. Okay, first one, a force may start motion in a body which was at rest. A body which was initially at rest, if you apply a force, it starts moving. For example, a ball lying on the ground, it's not moving, it's just at rest. You give a kick, it starts moving. So that's how force can start motion in an object which was at rest. Second effect is, force may change the speed of an object or direction of motion. Okay. So same way, a ball is rolling and coming at a less speed, and you give a kick and it's going to go at a greater speed. So it helps in changing the speed, or it can also help in changing the direction. Third one, a force may bring a moving object to rest. So while taking a catch in a cricket game, the fielder applies a force which makes the ball stop. Okay, so that's an example of force can bring a moving object to rest. And the last possible effect is, force can change the shape and size of an object. So this also you're familiar with the common examples like dough, or you can make any shapes by applying force. You can change the shape and size of that, and with that you can make different shapes. Play dough, and even the dough that we make for chapati, all those are come under this one, change in shape and size due to force. Okay, so these are the 4 things called effects of force. After studying all the effects, now we go to the definition. Okay, define force, or what do you mean by force? The answer goes like this. We usually define force as that external push or pull acting on an object. Okay, the first part of the definition goes like this: external push or pull acting on an object which changes or tends to change the state of rest or of motion of the object. Even if you don't say uniform linear, you can leave it for now. You can just say it's an external push or pull acting on an object which changes or tends to change the state of rest or state of motion of an object. Okay, this is the definition of force. Okay, now the next topic that we're going to see is turning effect of a force. Turning effect of a force. Now this may be a new term for you. So you will be seeing a small video which will help you or give you some idea about this topic, turning effect of force.
Think of a spanner loosening a fixed nut, or a child on a seesaw, or a door opening around a fixed hinge. All of these things are connected by something called moments. A moment is the turning force around a fixed pivot. The pivot is the nut, or the middle of the seesaw, or the hinge. We can have one moment acting, which results in a turning force. Or if something is balanced or in equilibrium, the moments are equal and opposite. To be balanced, this lighter child needs to sit further away from the pivot, and the heavier child needs to be closer. This is because the size of a moment is determined by the force and a distance. So the moment of the lighter person is 500 newtons multiplied by 2 meters, 1000 Newton meters. And the heavier person is 1000 times 1 meter to also give 1000 Newton meters. They're perfectly balanced on their seesaw. Did you notice that moments are measured in Newton meters, Nm, because force is measured in newtons, N, and distance in meters? Note that the distance must be the perpendicular distance from the pivot to force. Here's another example. Can you work out what moments the woman is applying to tighten the wheel nut? Pause the video and work it out. Did you get 3 Newton meters? Were you careful to change the 30 centimeters into meters? We can also place this formula into a formula triangle. Force equals moments divided by distance. Distance equals moments divided by force. And moments, as we already know, is force times distance. Here are 2 more questions for you to try. Pause the video and work them out. Did you get both questions right? For this seesaw, we do actually say clockwise moments and anti-clockwise moments. And for something to be balanced, the clockwise and anti-clockwise moments must be equal. So there we have moments. They're measured in Newton meters and are the force multiplied by the perpendicular distance.
I hope you understood the concept of moment of force. Now I'll explain it a little more. Okay. So the definition goes like this. If an object is pivoted at a point. Now I hope you understood about the meaning of the word pivot. It means it's a point where it's fixed and about which it can rotate. For example, in a door, that is called the pivot because it can open or close with respect to this. So in case of a spanner, you are shown the pivot. It will rotate about it. So that's called the pivot. Okay. So if an object is pivoted at a center, then force applied on the object produces a turning effect on the object along an axis passing through the pivoted point. This is called moment of force. So the first part of the definition goes, if the object is pivoted at a point, it's very, very important. The object should be pivoted at a point. Then whatever force you apply produces a turning effect on the object about an axis passing through the pivot. This is called moment of force. So now let's see some examples given in our book. The first example is opening and closing of a door. You know, when you think of a door, one side of it is fixed to the wall through hinges. We call it hinges, and the handle is in the other side, and we open or close by pulling or pushing it, right? So when you apply a force, the door undergoes a turning effect. Okay, so that's why it's an example of moment of force. Same way, this girl is pedaling a cycle. Okay, so this pedaling a cycle is also a turning effect. Okay, so because of the force that you apply, your wheels are turning or rotating. Same way, the third example, steering wheel. When the steering wheel is rotated, the car can undergo a turning effect. And then last example, when you use a lock, when you use a key to open or close a lock, you're basically applying a turning effect because of which the work is done. Okay, so these are the 4 examples from our day-to-day life about the turning effect of force. I'm sure you have understood the concept well now. Okay, whenever a body is pivoted and then when you apply force, the body will undergo a turning effect. For example, imagine this door was not fixed. This side of the door was not fixed. Okay, now what will happen? You just rest it on a wall and then you try to open or close. Do you think it will go? No, it is not going to turn. It will only fall down, right? So only because it is pivoted or fixed at one end, it's able to open or close. So that's the main condition for turning effect of a force. The next topic we're going to see is factors affecting turning effect of a force. What are the factors on which turning effect of a force depend. Okay, 2 factors. First one, magnitude of force. Magnitude means the value or the number, okay, the amount of force we can, okay, the value of force applied. Greater the force, greater is the turning effect. Yes, so when you're opening the door, you apply more force, the turning is going to be much faster, much greater. Same way in a steering wheel, if you're going to apply force, more force, the turning effect will be much greater. Okay. Second point, you can mark this as point number 1. Factors affecting, first point, turning effect depends on value of force or magnitude of force. Greater the magnitude of force, greater is the turning effect. Coming to the second point, turning effect depends on perpendicular distance of the force from the point of pivot, okay, or from axis of rotation. You can say axis of rotation also. So perpendicular distance, the whole term is important. The perpendicular distance of the force from the point of pivot. Okay, so if this is the pivot and the perpendicular distance, suppose if you are applying a force here, perpendicular, you know what is perpendicular? It forms 90 degree. Perpendicular distance between the force and this is called as pivot. You might be applying force here, but you should not take this distance. Okay, what you should do, you should draw a straight line which will make 90 degree with this line, and then that distance is called perpendicular distance. Yes, even though you are applying force here, we have to consider this as the perpendicular distance. That's the point here. Okay. Same way, more the distance, more will be the turning effect of force. Now based on these 2 factors, the next thing that you come across is formula. Formula. What is the formula for moment of force? Okay, we can calculate the value of moment of force. Formula for moment of force is force into perpendicular distance of force from pivot point. It is very important to write from pivot, distance of force from pivot point. Otherwise marks will be cut. Okay, this is a very important thing to be mentioned. So moment of force, I'll repeat again, moment of force is force into perpendicular distance of force from the pivot. Now these 2 were the factors here. Magnitude of force applied, perpendicular distance of the force from the pivot. Okay, so the moment of force is force multiplied by perpendicular distance of force from the point. So you'll be using this formula in numericals and other applications. Okay, now there's another name for moment of force. It is called torque. T-O-R-Q-U-E. Torque. Okay, and its symbol is tau. Tau. Okay, it's a Greek alphabet or something. It's tau. Torque. Okay, next we are going to see about anti-clockwise and clockwise moments. Let us try to understand this clockwise and anti-clockwise moment using this example of lock and key. You all know what is clockwise, right? The direction in which our clock rotates. So always the needle of the clock rotates in this direction, right? I hope it never rotates in this direction. Okay? So this is called clockwise. The direction in which the needle will usually rotate, that's called clockwise. Now if this is called clockwise, then the opposite direction is called anti-clockwise. Anti-clockwise. This means if something rotates from here to here, clock doesn't rotate like that, but there are other things that can rotate in this direction, then it is called anti-clockwise moment. Okay, so same way anti-clockwise. Now same, we have 2 in moment of force also we have clockwise moment and anti-clockwise moment. Now if the turning effect produces a, so now when this lock is open, when I close the lock, I apply moment of force, I apply force in this direction, so that is anti-clockwise moment. Okay, when I have to open, I have to apply force in this direction, that is clockwise moment. Force is rotation is in this direction, so it's called clockwise. The other case, rotation was in this direction, it is called anti-clockwise. So in any turning effect, door you can open and close. When you open, it opens in one direction, close in another direction. Steering wheel, everything can undergo both clockwise and anti-clockwise moments. Now come to the definition in your book. If a force produces clockwise rotation in an object, the moment of force is said to be a clockwise moment. So if they ask you define clockwise moment, this will be the definition. If a force produces clockwise rotation, it is called clockwise moment. Then if a force produces anti-clockwise rotation, then it is called anti-clockwise moment. That's all. So these are the two definitions of clockwise and anti-clockwise. Now the next heading is SI unit of force. SI unit of moment of force. Now just now we saw the formula for moment of force. Moment of force is force into perpendicular distance perpendicular distance from the pivot. Perpendicular distance of the force from the pivot. Now, so the unit of moment of force will be unit of force multiplied by unit of distance. Unit of force, I hope you're familiar with this, Newton. Okay, unit of force is Newton and distance is usually measured in meter. So you have Newton meter. So moment of force, unit of moment of force is Newton meter. Okay, in words it's Newton meter. Okay, now we have some numericals based on this formula. Before we go into the numericals, I want to talk something about SI and CGS system. In the previous chapter, in the chapter which we did previously, I spoke about it, but I heard some children did not understand it, so I'm going to talk about it again. Okay. So earlier they were using a system called Cgs system. C stands for centimeter, G stands for gram, and S stands for second. So length is measured in centimeter, mass is measured in gram, and time was measured in seconds. This was the unit that they were using before. But then they found centimeter is a very small unit. Now if I have to say what is the distance between our school and the Selakwi main road, if I have to say in centimeter, okay, it will be 3500 centimeter. Okay, so like this, if I say in centimeter, suppose I have to talk about the distance between Earth and Moon. Okay, in centimeter it will be very huge. Okay, so they found this units small, so they decided to change the units. For length, they changed the unit into meter. Mass, in SI system, mass is usually measured in kg. Time in both the systems is second. In both the systems it is second. Okay, so this is called SI system, and this is the system that is used all over the world for any measurement. So whenever we solve the numerical, we are supposed to have all the things. Even if they give the length in centimeter, you're supposed to convert it to meter. If they give the mass in gram, you're supposed to convert it into kg. So then only your Newton is also an SI unit. So if it's given in centimeter, you should make sure you convert it into meter before solving the numerical. Okay children, let's start with the numerical now. Let's start with numerical number 1. Okay, the first example number 1, sorry. Page number 45, example number 1. A force of 2.5 Newton acts on an object at a normal distance of 40 centimeter from the turning point. Calculate the moment of the force. First, let's write what is given. So, it's given that force is 2.5 Newton. Okay, and perpendicular distance. Okay, distance is 40 centimeter. And what you have to calculate? Moment of force. Now, as I explained you just now, before solving the numerical, you should check whether everything is in SI system. Now, distance, SI unit is meter, but it is in centimeter. That means we have to convert this into meter. So, what I should do to convert it into meter? I divide it by 100. So, 1 0 will get cut. So, you can just keep it like 4 by 10 meter. Okay, Newton is an SI unit. I don't have to make any changes. Now let me come to the formula for moment of force. Moment of force is force into perpendicular distance. So force is 2.5 Newton multiplied by perpendicular distance is 4 by 10. Now 2.5 into 4. 2.5 into 4 will be 10. It's 100, and decimal I put here, so it will become 10 upon 10. So it will cut, and the answer will be 1 Newton meter. So moment of force is 1 Newton meter. N should be capital, M should be small. Okay, so please make sure you write N in capital letter, M in small letter. Okay, I hope you understood this example. Now come to example number 4. Okay, page 46, example number 4. A technician opens a nut by applying a force of 8 Newton using a spanner of length 18 centimeter. If he wants to open it with a force of 6 Newton, what would be the length of the spanner used? Okay, so example 4. So it's given a technician opens a nut by applying a force of 8 Newton. So force of 8 Newton is applied. Spanner of length, that's the perpendicular distance. Okay, length is the distance in this case. So it is 18 centimeter. So before going ahead, you will convert this into meter. 18 by 100. So if you want to cut it by 2, it will be 9 by 50. So 9 by 50 meter. Then moment of force will be, force is 8 into distance is 9 by 50. So it will be coming in decimal. So you multiply this. 9 8s are 72 upon 50. So it comes out to be 1.44 Newton meter. 1.44 Newton meter. Okay, the question is not ending here. It goes on to say, if he wants to open it with a force of 6 Newton, what should be the length of the spanner used? What should be the length of the spanner used? So, to open that nut, 1.44 Newton meter moment of force is required. Okay, so the second case, so this is, you can take case 1 and case 2. Now for the second case, moment of force will be the same, 1.44 Newton meter, but the length is different. That is, the distance, perpendicular distance is different. Because the length we have to find, length of the spanner we have to find, that is distance we have to find. Force is 6 Newton. The person who is opening, earlier he applied 8 Newton, now he has only 6 Newton force. Maybe he is tired, he is not able to apply so much force, so he is applying only 6 Newton force, And to produce this much turning effect, what should be the length of the spanner? That's the question. So moment of force is equal to force into distance. Now moment of force, so we have to find distance. So what will be distance? Distance is equal to this. Force will come to the denominator because there is multiplication. When I bring to the other side, it will come division. Okay, so moment of force divided by force. So our moment of force is 1.44 and our force is 6. Okay, so 144 by 600, if I take, it will be 0.24 centimeter, meter, sorry, 0.24 meter. Or if you want, you can convert it to centimeter, it will be 24 centimeter. So this is a formula that we get from the main formula, that is, this is our main formula. From that I can get this formula also. Distance is equal to moment of force by force. We can also get, if they have asked you to find force giving the distance, I'll be using this formula. Force is equal to moment of force upon distance. Force upon distance. So in the numerical they can give you any two values and ask the third one. It can be this, this or this formula. Any one can come. Hope you have understood the numericals, children. If you see in the diary, there will be some homework given. Make sure you complete it. Thank you.